GM, what's up clubbers? Welcome to Web3 Club. In today's video, what we're going to learn is how do we do lazy minting for NFTs or tokens or whatnot. Lazy minting is nothing but minting in time. That is, when you sell a token or an NFT, only then the user ends up minting that NFT. This is helpful if you're creating a marketplace or a minting dApp where you don't want your creators to spend for gas until and unless they find a buyer. What will end up happening is the buyer will end up paying the gas for minting the NFT and they will receive it in their wallet. This is a pretty popular technique employed by marketplaces such as OpenSea and whatnot. It generally makes for a much better user experience for the creator and it doesn't make a big difference for the person who's purchasing the NFT. And a big shout out to Discord members who had asked for this specific tutorial. But before we get started, please make sure to hit that like button and subscribe to this channel if you haven't. If you want to send me a message, please leave it in the YouTube comments, or if you have a specific question, come join my Discord server. There are a bunch of people just like you and me who are trying to help each other out. Alright, with that said, let's get started. So now, broadly speaking, there are only two steps for lazy minting. First, we create the smart contract. Second, we create the backend code, the server-side code, the centralized code, which helps us with the lazy minting. In the lazy minting smart contract, what we do is we accept a signed struct or a voucher which checks the validity of the signature. The signature has to be issued by a trusted signer, which is generally available on the server of the service providing this whole service. The centralized server signs the voucher and sends it to the user so that they can use that in the transaction and mint the NFT that they can get into their wallet. Now, how will we accomplish this signing and everything? So what we're going to do is we're going to rely on this EIP called EIP 712, which allows us to standardize signing a typed data structure. So what we can do is basically have a key value pair and have them signed on the server side and then send that signature to the smart contract, and smart contract and then figure out whether the signature is valid for the key value pair sent. If you want to get into the details of it, you can go and read this, but I'm not going to cover this again. I've already covered this in a couple of my old videos, so you can check them out. Next, what I'm going to do is open the OpenZeppelin wizard. What I'm looking for is an ERC721 smart contract. Let me just name it Lazy Mint, or actually Lazy NFT. Alright, with the symbol LNFT. I want to make this mintable and I want the URI storage module because what I want is every NFT will have its own URI. You can of course move forward and make a centralized URI which you can keep updating, but generally speaking this is an easier way out. I don't think I need anything else. I can just open this in Remix. So this is what the contract looks like. I'm just going to increase the font size so that it is visible to everybody. Now I need to import one more thing, which is the EIP 712 module from the OpenZeppelin contracts library. So what you can do is just copy paste this whole page, but I already have it in my clipboard, so I've just copy pasted it. I'll also add at 4.7.3. So it's at OpenZeppelin contracts utils cryptography draft-eip712.sol. So this eip712.sol will help us with all the cryptography related to EIP712. So the next thing that I'll do is add EIP712 over here so that we are inheriting from EIP712. Now EIP712 also needs us to be called from the constructors, and it requires two different things. The first is the domain, or basically some name, and the second is the version, which will again be a string. You can just put it 1 for today. So I've created two variables which are constant signing underscore domain and signature underscore version. These are the two things that I will send over here. Alright, once that is done, the next thing that I want to do is create a redeem method. So we already have a safe mint method that we can use, but instead of that, what we're going to do is create a redeem method. The redeem method will accept the voucher and the signature and make sure that it is valid, and if it is valid, it will mint an NFT for the user. Now before that, I need a struct for the lazy NFT voucher, and this is what the struct looks like for me. The struct has token ID, so this is the token ID which will be minted for the user. It has the price, which is the minimum amount of money or ETH the user needs to send. Then there's URI, which will be stored on the NFT token ID so that the token URI can resolve to the correct token or correct metadata for the NFT. And we also have a buyer, which is where the NFT will be redeemed to. So whoever is the buyer, only they will be able to redeem the NFT to their own wallet. And the last thing is signature. We don't really need to put it in a struct. We can also keep it different from the struct. I have just decided to put it in the struct. This signature is the signature which will be generated by signing the voucher from our backend. We will come to that later, but right now we're just working on the smart contract. The next thing that we'll create is a verify function which will verify whether the NFT voucher, the lazy NFT voucher that we're sending, is a valid voucher and who does this voucher resolve to, who is the final user, the final signer that has signed this NFT voucher. So to do that, what I'm going to do is I'm going to copy paste a function that I've already written. So this is what the function looks like. The function's name is recover, and what we will do is write lazy NFT voucher, and then this will be a call data and the name of the variable will be voucher. This voucher is the voucher that will be signed and basically given by anyone who's calling this function. Now in this function you can see that there is a underscore hash typed data v4. Now where is this method coming from? This method is coming from the 712 module that we have inherited from. Now here what we have done is you can just copy this. It's a bunch of cryptography that you don't need to understand, but what we're doing is we are finding the hash of ABI encoded these things. And now in the ABI encoded things, what we have is first, what should the voucher look like? And the voucher has token ID, minimum price, URI and buyer in that order. And similarly, we have token ID, and actually this should be price. Similarly, it should be price here. Token ID, price, URI, buyer. Notice that URI has a KSEC 256 bytes. That is because we can't really pass string here. So what we are doing is we are ABI encoding all of these things and then creating a KSEC 256 hash. We call this a digest, and then using this digest and the signature in the voucher, what we'll do is we'll figure out who is the signer and we will return this signer. Now it's pretty simple. If the signer is somebody that we trust, what we will do is we will let the user mint it. If it is not somebody who we trust, then we will not let the user mint it. So the next thing that we'll do is remove the only owner method over here, and then what we'll do is we'll write require recover, but we don't have the voucher details coming here. So instead of all of these values, what we can do is just call lazy NFT voucher, call data voucher, and then what we can do is just write voucher over here. So this recover returns a signer, and then that signer should be equal to the owner of our smart contract. Now this need not be the owner. You can also have a different variable where we can store this value. So for example, what I'm going to do is I'm going to create a new variable called address public signer, and that will be taken in the constructor. So I'm going to write address underscore signer equals underscore signer. Now we have a signer that we allow, or actually we can just call it minter rather than signer because that is much more clearer. So now what we do is we make sure that the recovered address is the same as the minter. If it is not, wrong signature or something. Okay. But if the minter is the correct signer, what we need to do is just put voucher.buyer as the minter, and then voucher.token ID as the token ID. And similarly, we need to set the token URI. So voucher.token ID and voucher.URI will be the URI for this. Now, what some people do is they mint the NFT to the author first, and then transfer it from the author or artist to the user. You can also do that. That way what happens is it ends up paying for a little more gas, but the artist can have some provenance on the chain that this was me, I made this and then I transferred this to somebody else. You may or may not decide to use that. Now one thing is missing. We haven't taken in consideration the price yet. So what we'll do is we'll make the safe mint function payable, and we'll also require that message.value is greater than equal to voucher.price. Alright, otherwise not enough ether sent. By the way, when I write ether sent, it generally means the primary token of the chain. So for Polygon it is Matic, for Arbitrum it is Ether, for Optimism it is Ether, and for Ethereum it is Ether. For Avalanche it might be AVAX, for Shardium it might be SHM. Actually not might be, it will be. Now before we compile, make sure to add this KSEC 256 to the lazy NFT voucher signature over here, the method signature over here, because otherwise it will not work. And that is it. This is basically what we need to do. Let's go ahead and deploy this. Now to deploy this, what I need is the address for Minter, but fortunately what I know is the private key of this specific address. So I'm going to deploy from this address. Before that, I'll copy the address, and then I'm going to deploy from the second address and make the first address as the Minter. And why am I going to do that? Because I have the private key of the first address. So I'm going to click on deploy, and the deployment has succeeded. Now you can see there is a safe mint function that accepts a tuple, a voucher basically, and there is also a recover function which accepts a voucher. So what I'll do is I'll generate a voucher and then send it to recover and make sure it returns the same address that we need. Now what I'm going to focus on today is mostly the JavaScript part, as in how do you generate the signature. So what I'm going to do is I'm going to do it in the front end because it is just easier for users, for the viewers, for you all to grasp it. But what you should ideally be doing is you should be ideally using all of this code on the back end, and whenever somebody agrees to purchase, you sign something for them, give it to the front end generates a new transaction request and gives a MetaMask pop-up or a Wallet Connect pop-up to the user clicks transact, and the transaction should go through. But today what we're going to do is just explain how the whole thing works. So I'm going to do it on the front end and show you how it actually works. But make sure when you're doing it on production, you take that part of code and put it on the server and then return the signature and all those nice juicy stuff to the front end, so that the front end can prompt the user to complete the transaction. So I have my terminal. I'm going to cd to a folder and create a new lazy minting folder and cd to that as well. And I'm going to open Sublime Text here. Also, I'm going to create a new index.html file. In the index.html file, I'm going to create a title called lazy minting, and now I'm going to import ethers.js. You can also do this with web3.js, but I'm going to show today with ethers.js because it is generally much more accepted. So I've imported ethers.js. It is a very simple import. I'll have all the code available in the description so you can copy and paste it. So the next thing that I'm going to do is create a script tag and now start putting our code here. What we're going to do is first create the signer from the private key that I already have. So I'm going to paste this, and this is how you create a signer. New ethers.wallet, and then we pass the private key. With this private key, I'm going to sign the messages that I will be sending to the remix. Next, we also need the signing domain name and the signing domain version. Now, where do you get these values? This is the value that you've already put in over here, the signing domain. The same value needs to be here, and the signing domain version should be the same as over here. And make sure that it is string. We also need the chain ID, which in the case of remix is 1, and we also need the contract address, which for our scenario is present over here, and I copy this and paste it over here. So these are the variables that I will be needing. Now, as per EIP 712, what I also need is something called domain. And how do I create a domain? Just write const domain equals, and now we need to write name, which will be the signing domain name, the version, which will be the signing domain version. I also need the verifying contract, which will be the contract address that we've already copied, and the chain ID, which will be the chain ID, or I can also write this as like this. Next thing, we need a function to create the voucher. So let me just generate or create a new function, async function called create voucher. All right. Now this function takes in 4 parameters: the token ID, the price, the URI, and the buyer. So here inside we create a new voucher like this with token ID, price, URI, and the buyer. We also need to define types, and this is something where a lot of people make mistake. Make sure to have your types in correct order. So now how does this work? The types will be an object with the key of the name that you can copy directly from here, the signature. So the lazy NFT voucher is the name that we need. And then it will again be an array actually of objects. The objects have a name, which will be token ID here, and a type, which will be uint256 here. Okay, so this is for token ID, and the next thing that we need to add is the price, the URI, and the buyer. Now the order is important, and the order that you want is basically the order that you have over here: the token ID, the price, the URI, and then the buyer. Make sure there's no space after the comma over here. So we have token ID. The next thing that I need is price, which will again be a uint256. The URI will be a string, and then the buyer will be an address. Now that we have these things, we need a signature that we can generate now, and that will be an await with a signer dot underscore sign typed data, not date, data. The first thing that will accept is domain, the next is the types, and the third is the voucher. All right. So make sure you have a code which is very similar to this, and then the last thing that I'll do is return the whole voucher and the signature. Now just to make things easy for me, just to make things easy to copy paste, what I'm going to do is create another function which will basically call this create voucher with the specific arguments. So I've pasted this, and I have this first argument which is the token ID, the second argument which is the price, the third argument which will be the URI, the fourth argument which will be the buyer. So we can have a specific buyer as well. So let me just copy this address and make them the buyer, and that is it. This will give me the voucher, and the next thing that I want to do is console.log this voucher. So with the log will be looking like token ID, price, URI, and then the buyer. Okay, the buyer also needs to be in the quotes. So we have this thing ready. Now I can just go and open the terminal and write python -m simple http server. So I'm just starting a simple http server. You can also run this with PHP, Node.js, whatnot. I'm just using Python because that I have handy. So the next thing I'll do is I'll go to localhost port 8000, and you can see that I have this function called main present over here. I'm just going to call this function, and it gives a console.log with this value. Now I'm going to copy this and go to remix, and let me just increase this and just paste this over here. And once I do and click on recover, you can see that it has recovered with a specific address. The address starts with 5B3D 38D and then ends with DDC4, which is exactly the same address that we have over here, 5B3 and EDDC4. Okay, so the recover function is working perfectly. So the next thing that I'm going to do is just paste the whole thing over here with SafeMint. And remember, the amount of ether that I require right now is 0 because that is the value that I have sent. So if I press SafeMint, it should work perfectly. And you can see that the token ID that I sent was 2. So if you want to check out the URI for the second token, you can see that it is URI because that is what I had written, and the owner of the token ID 2 is the address that we had given. So now let's change this to a different address. Okay, let's take a different address like this one. So I'm going to paste this over here. I'll make sure that we need to send 50 way. Okay, and I can't have the token ID 2 present again because this will give me an error. So I'm going to change this to 5, and I'm going to save this and refresh here and write main again. This time I get a different signature. I can go back to any of the accounts over here and check the recovery. The recovery should be from 5B, the 3D and whatnot, and it is the same. Now before I mint, actually you can see that the owner of token ID 5 is nobody. The transaction reverted. Okay, so the token ID 5 requires 50 way. Now first thing first, what I'm going to do is I'm going to just send 0 way. Okay, and if I press save mint, you can see that there's an error which says not enough ether sent. All right, so now what I'm going to do is send 50 way, and the moment I do that, the transaction succeeds. And if we just go there and check the owner of 5, you can see that it is the address that we had sent, and lo and behold, that is how you do lazy minting. Now of course, in the production, what you would do is you will have this specific code, the signature code in the backend, and then you will send this to the front end, and front end will make sure that the data, the signature that it has received, with that it will generate a transaction for the user to approve or sign or confirm or whatnot. If this video was helpful, please make sure to hit that like button and subscribe to the channel if you haven't. If you want to send me a message, please leave it in the YouTube comments. And if you have a specific question, come join my Discord server. There are a bunch of people just like you and me who are trying to help each other out. Of course, this code will be available in the description down below, so don't worry if you miss something. And if you like what I'm doing, please consider supporting the channel, share this channel with others so that I get some sort of reward out of this. Thank you so much for watching the video. I hope to see you again next week. Till then,